This is TWIS, This Week in Science, episode 553, recorded on Wednesday, February 10th. How much do you love science? Hey everyone, I'm Dr. Kiki, and this is This Week in Science. We are back again to fill your heads with designer babies, bacteria, and love of science. But first...
Disclaimer, disclaimer, disclaimer. With election season well underway and the fate of science hanging in the balance, many are calling for change. Some may wonder if we are ready to take the next big step and elect as president someone unlike any that has served before. Someone with a unique perspective who could truly show how far we've come as a nation. We have that opportunity to take that step and elect our first robot president. Now, I know it may not seem logical, but that's only because you are not a robot. In seeking the nomination, our robo-candidate could personally reach out to each and every potential voter by making simultaneous, non-pre-recorded robocalls. Our robo-candidate could not only stay on message like a champ, but could avoid overt Rubio-esque repetition by creating and sticking to a playlist of talking points. And then, think of it. A president that never sleeps. The emergency call that comes at 2 in the morning, no different than the one that comes in early afternoon. And most importantly, perhaps, a president who, above all else, ends every speech to the nation with the words, "This Week in Science," coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kirsten and Blair, and guest Paul. Welcome.
Good science to you, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. TWIS is back. We've got so much of science. You know, this week is crazy. This week, Friday, Darwin Day. So we're celebrating the 207th birthday of Mr. Darwin and the ideas of natural selection that came along with him, thanks to him, and his superior intellect, right? That's pretty awesome. It's also World Radio Day on Saturday. If you had your TWIS calendar, you'd know that.
It's true.
You would know that. TWIS calendars sold out! Woohoo! Thank you, everyone, for ordering your calendars. That's pretty awesome. Thanks for supporting TWIS. And now you're informed all year long. You're going to be that select few who knows when things are happening. Like Valentine's Day. And
Oh my
Sunday.
gosh, is that coming up?
That's coming
You
up.
I
guys-
on
need to do
Sunday.
something on this.
I'm all Twitter-pated.
And this is our love episode.
Science! The
Love-
science of love!
That's right. Love science. We need the love science. Right? Love Boat theme song, right? Reference? Got it? Okay.
Love science.
There we go.
Always something exciting and new.
There we go. There we go. So many things on the show today. We have an interview, which is very exciting. Dr. Paul Knoepfler is joining us. He is going to be talking with us right at the top of the show tonight. He's written a book about genome editing and the future of reproduction. I also have a bunch of science news. I have stories about insightful slime, bear bellies, and seasonal senses. Some fun stuff. What do you have, Justin?
I have slack-jawed ancestors.
Okay, it's true.
Hey, so do I!
I've also got T. Gandhi going ape, and if time permits, allergic reactions to vibration.
Oh dear. And
Uh-oh.
Blair, what's happening in the allergy corner?
In the allergy corner. I don't know about that, but in the animal corner, I brought some Chimp PDA. Aw. And it wouldn't be Valentine's Day without some invertebrate sex.
And from what I've heard,
Yeah.
this may be the greatest invertebrate sex story ever.
of all time.
I am so stoked, you guys. And yes, this beats out traumatic insemination. So stick around.
Yeah.
All right, this is bigger than slugs sticking themselves in the head. Here we go. You heard it here. Stick around till the second half for Blair's Animal Corner. All right, we are getting this show started in a fun way. We're going to be talking about designer babies, kind of, sort of, pretty much. We are talking with Dr. Paul Knoepfler. Welcome to the show.
Hello. Thanks for having me.
You're welcome. Thank you for joining us. I'm really excited to be able to talk with you. So your background, you're an American biologist, writer, and blogger, associate professor in the Department of Cell Biology and Human Anatomy, the Genome Center, and the Comprehensive Cancer Center at the University of California, Davis School of Medicine. Aside from the School of Medicine part, my alma mater. So that's exciting.
That's right.
Yeah. And you blog regularly on the topic of stem cells, and your blog is located at ipscell.com. You've also written a book on stem cells that was published back in 2013, kind of a primer for anyone who needs to know anything about stem cells. And this year, you've reached into a different area, related but different, publishing a new book called GMO Sapiens. You can see it in the background if you're watching the video right now. The Life-Changing Science of Designer Babies, and it discusses the science of human genetic modification and covers CRISPR gene editing, which we talk a lot about on this show. And your focus is its possible use in humans, cloning, eugenics, transhumanism, and if that isn't a list of like terrible, evil, dystopian sci-fi novels, I don't know what else is.
Evil laugh in the background.
Yes. So to get this started, gene editing, human genome editing, should we be scared?
You're asking me. Yeah, I don't know. I don't feel really scared at the moment myself, but I do love sci-fi, and I love gene editing. I've been doing that for a long time. But in the old days, we used to call it genetic modification or mutations, knockouts, things like that. And it was maybe about 2 years ago I noticed this thing CRISPR, right, kind of coming up in the scene. I would go to meetings and everyone was talking about CRISPR, and I was like, what's CRISPR, And just hearing more about that and hearing about people talk about using stem cells to clone people. We can make gametes from human stem cells. And, anytime you have a step of human reproduction in the lab, you have the fun opportunity of putting stuff into an embryo, right? And so it all sort of fell into place for me. Like this seems like something we need to be talking about. So I'm not scared. I'm actually really interested in it, and I do think it wouldn't be a bad idea to be cautious about it and talk more about it. So this kind of opportunity is great.
Yeah, we agree with you here. I think the discussion is one of the and education, so that people can inform themselves about the topic and know what's going on, and then make their decisions, right, in an informed manner.
Right, exactly.
So a decision like I believe it was the department, the head of the department or the head of the NSA today
Mr.
saying
Tapper,
yes, this was a pretty big thing, coming out and saying CRISPR is a threat to our national security. How would that work? Why would it be a threat?
Yeah, so that's something I cover in the book briefly, and I've tried to I don't want to have sort of a how-to, CRISPR weapons of mass destruction thing, but
people can figure that out on their own.
Yeah, I mean, if they're motivated, right, they can figure it out. But the general idea is to use CRISPR for something called a gene drive, and so gene drives are this cool, semi-hypothetical, semi-real thing where you essentially make a gene that's selfish, and that gene self-replicates and makes more of itself at the expense of its sister copy that's wild type. And so with CRISPR, you would do this by CRISPRing in not only like a mutation, but also the CRISPR machinery itself. So you've kind of made a copy of CRISPR, in a chromosome, and you've told it, whenever you see a sister chromosome that's wild type, duplicate yourself at that other one's expense. And so gene drive, I think it's been tested in the lab, like in fruit flies and stuff like that, behind like double, locked doors, biosafety, whatever, because you don't want, a flying fruit fly with gene drive to escape. And it seems to work. So within, not a huge amount of population doublings, basically the selfish gene is taken over. And where this kind of comes into play with national security or things like that is this would, in principle, work in people. It would work in any sexually reproducing species. And there wouldn't be a whole lot that we could do about it. So it could be a pretty insidious kind of thing. I don't want to go into too much detail on how it would work, but there are ways it could be pretty scary.
Right, but some of the good ones are, I believe, not just fruit flies, but in the lab, mosquitoes have been edited to fight malaria. And,
right,
and now with Zika, being in the news,
Yeah, so I've seen a couple articles saying, mosquito, your time's up. Let's just wipe mosquitoes off the face of the earth. Or like a little more limited one was, let's wipe off the face of the earth the Zika carrying mosquitoes or transmitting mosquitoes, and let's do it using gene drive. And so there's different ways you could do that. You could engineer a gene drive that would make the mosquitoes, they still can breed, but all the offspring are sterile, or all the offspring are male, or et cetera, or they make a toxin that manifests in larvae. And so seems like a pretty cool idea. On the other hand, maybe mosquitoes, they do stuff. They don't just bite people. And I've talked to some people who are more hardcore geneticists than I am, and they're pretty scared of gene drive actually getting out into the world because they're worried about things like, unintended consequences, horizontal transfer, like maybe one mosquito, you think it's just going to be wiped out by this anti-Zika gene drive, but then it transfers it to another mosquito that you didn't think could happen, and then to another bug of some other kind. And so there's sort of like massive upside and massive downside to this kind of stuff.
Yeah, I think especially with stuff like the horizontal gene transfer, we don't, in multicellular organisms, we don't understand it enough. We see it in plants because you have pollen spread all over the place, and we know we see it in bacteria because bacteria are constantly cutting up their genomes and like giving each other. They're just like, here's this gene, I'll take that gene. They're like they're just playing dice and gambling with genes down there. But in terms of other organisms like mosquitoes, insects, what do we actually know about how often they cut things apart and just hand things over? How often are little genes in bits of saliva? How often are little genes, carried to other organisms?
Yeah, I think it's probably more often than we realize, but exactly how often, I don't really know that we know that. And so it just feels like once you get a gene drive out there, can you reel it back in, or are you pretty much stuck, And it's interesting because I've talked with George Church about gene drive because he's really fascinated with that, and he's published some of the earlier papers on the theories of gene drive, and he says you can do a reverse gene drive to kind of cancel out the first one should it go wrong. But then it's sort of like, it seems like, what if something goes wrong with the reverse gene drive? And so, it's pretty unpredictable, I think. So exciting stuff, kind of breathless stuff in science, but pretty much it would be an experiment on the whole world, so no big deal, and
I think that's the big, the big concern is, we are using the Earth as a laboratory, but we really shouldn't be doing that because we only have one.
But it's human nature, right? I mean, like, I love science, and as much as I'm somewhat cautious in this book and talking with people, I love CRISPR. We use it in my own lab, and it's really cool. And so it's human nature to experiment, right? So. Right,
and CRISPR is an amazing tool, and it's not, there are the things we go to these sci-fi extremes of what could happen, but that's not necessarily what is going to happen. And the majority of use is going to be this just as a tool to help geneticists figure things out better.
Oh yeah, and what a tool it is. I think it's probably at least 10 times faster than when we used to do, even just a few years ago, making genetic, modifications in different organisms, and it's probably 100 times cheaper than the other methods. So it's pretty awesome. We can do things in human cells too, where we used to be limited to, say, mouse cells, rat cells, whatever. So like in my lab, we're studying stem cells and cancer, and we can do cool stuff with CRISPR in actual human cells, human, excuse me, patient samples, things like that we just couldn't do before. So it's exciting.
It is very exciting. I think it really is. It's just the technology is opening up doors for researchers that they just never had before, or like you said, were just really expensive as to be prohibitive.
Yeah, for sure. And where I got more concerned and what kind of pushed me more to write the book is I started seeing people say, let's do this in people, and I felt like, yeah, they're kidding, right? They're not really serious, but they're pretty serious, and so like George Church is a fantastic scientist, and I think he's really cool, but he's he'll do stuff like throw out a list of 10 genes. Maybe we should think about modifying those genes in people. Maybe they could have stronger bones, bigger muscles. And I know he's very much into safety, but he's just so enthusiastic. And then, there are other people out there. There's some philosophers in the UK and here in the US. And you guys, I don't know if you guys saw Steven Pinker's piece last year where he was like, bioethicists, get out of the way, full steam ahead on CRISPR. And
wait, what?
Yeah, so really? Steven,
I didn't see. Oh, what?
Yeah, he got this. He sort of catalyzed this big firestorm by saying, let's go for it on human modification, and bioethics be damned, and I think in part he did it to sort of start a discussion. So I can't fault him for that, but and I'm not a bioethicist, but I do think talking about human modification, especially in the germline. Not so much, with somatic gene therapy stuff. I think there's some ethical issues there, but certainly with the germline stuff, there's a role for bioethicists to come in and say, maybe we should be thinking about X, Y, Z, and so it's interesting. There's some people who are really gung ho about let's go ahead with human modification, which I didn't realize. And
I think that philosophy also might have something to do with the decades-long issue we've had with just working with stem cells. And if we open this up to a public understanding, a really too generalized public misunderstanding of what's actually taking place, nothing will be able to get done. And so maybe there is this, like, while we don't have a whole lot of definition, right? While there's still a gray area about what we're allowed to be doing in the lab and what we aren't, do it now. Otherwise, we may not get to do this.
That's a good point. Yeah, I hadn't thought of it that way. And in fact, there was a hearing last year in Congress where Jennifer Doudna and some others were asked to testify. So I think the politicians are starting to get a little bit of the wind of the genetic modification. Then we saw the national security guy Tapper today talking about it. And in fact, the federal spending bill for this year, they put in a little rider saying that the FDA could not consider any applications for human genetic modification in this fiscal year. So it's temporary, but I think it shows it's on their radar screen. And that may be why there was this meeting of the National Academy of Sciences in December that I attended, trying to figure out, what is the best path forward. And I think that might be why the organizers in their closing statement didn't endorse a moratorium, because I think they were worried that might, sort of encourage some legislators to make a law, that would be inhibitory to the science. And in fact, tomorrow there's another meeting of the National Academy of Sciences where they're having a public meeting to talk about this too. So it's interesting that's just going to happen tomorrow. So.
And if we did have a albeit small generation of stronger, smarter, better boned, bigger muscled individuals who owed their upbringing and their advantage to Chris, we could use them to our advantage. So.
Or they could use us.
Well, no, that would be the same thing, right? They would be able. It would sort of be the con. Group.
This is starting to sound like a comic book.
Right? I mean, it sort of is, though. I mean, in a way,
Yeah.
this is what we're talking about. We're talking about the potential. Well, I mean, in the extreme, we're talking about the potential to create superhumans. We're also talking about
In the extreme.
in the
Yes.
extreme, and the other and the actual priority is to get rid of weakness. You know, it's not so much about buying happiness, but paying off misery.
But then right in the middle is, I'd like a blue-eyed, dark-haired, tall boy, please.
Sure. And perhaps as ridiculous as that sounds, perhaps that pays for the research and the funding to do the work that then cures diseases, that maybe reverses diseases that are already in play. I mean, there is going to be that sort of mall mentality use of science, but if that's what it takes to pay for the good work that science can do, this has always been the thing. You know, it's always been.
That gives me the heebie-jeebies still, and I can't tell you exactly why.
But
And that whole tall and blue-eyed thing. This is like star-bellied sneeches.
Yeah.
Right? This is like Monkey
That's
McBean's
exactly what it is.
Star adding and removing machine. The trends will constantly be different, and different regions will want different things, and after
people
they
have
have
been
too many
doing
people
it
that
for
look
years.
alike, it'll go the other way.
And people have been doing it anyway, knowing that, knowing there's a hypothesis that blue-eyed people have become more prominent, gained a higher frequency in the population because it was beneficial for men to have wives with blue eyes, because it's a recessive trait. They would know whether or not their wives were sneaking off on them. So there are these ideas that that knowing a little bit about inheritance, that having this, the way that things get passed down, that brown-eyed parents often have brown-eyed children. Brown hair ends up begetting brown hair. That these traits, you have a tall wife, tall husband, you're going to have a tall child. These are traits that are physical and tangible that people have been choosing for years, whether subconsciously or completely on purpose. And so how is it any different to just choose?
I think it's somewhat different because you're going in there, right, and you're sort of tinkering around and changing up stuff.
I am playing devil's advocate.
Of course, yeah. And
You're good at that.
getting back to the heebie-jeebies, I've had some of those watching. There's this nickname for the CRISPR animals out there called CRISPR critters. I don't know if you guys have seen this, but
I haven't.
yeah. So last year there was this whole flood of CRISPR animals that sort of popped onto the scene, and there's some pretty wild ones. Like there are these, you know how there's like pigs and there's mini pigs. Now there's micro pigs that were made with CRISPR, that when full grown you can like hold one like this in your hands, and like a little kid can carry it around like their doll, or whatever. And, it sounds pretty cool, but a little micro pig, And then going the other direction, they're basically like super pigs now that are, they have a mutation in the myostatin gene introduced by CRISPR, and they're like the Arnold Schwarzeneggers of the animal world. So they have I think they have like twice as much muscle and less fat. Yeah, double muscle pigs. And there's also double muscled beagles that came onto the scene that are like these super buff beagles.
But this is exactly what we need CRISPR for, though. I mean, this is actually this is the thing that's going to save the world from starvation and depletion of energy resources. If we just made this the standard to make micro-humans going forward, suddenly,
I've heard that. Yeah.
Suddenly we have all this land. Your tiny one-bedroom New York apartment that costs a fortune. Now it's 3 stories and it's 14 rooms. It's like this is what the potential is for downsizing humans and making us really, really small, is that we can then have another run at expanding and exploiting resources on the planet.
Yeah, I mean, that sounds pretty cool. And I think there was a Kurt Vonnegut book where he envisioned a future. I think it was the Chinese in his book that discovered how to make people who are micro people, and essentially they took over the world because it was such a good idea. I can't remember which Vonnegut book it was, but
Oh my gosh, that sounds amazing.
Yeah, I don't know the book. I know there's a Dead Kennedys song that speaks to this. But there would be some who in this song there's some who actually didn't make the conversion, and they became the rulers of the planet because they were giants.
It's funny because in an earlier draft of my book, I had a section on GFP people, fluorescent people. And one of the editors who was reading my book was like, why would you even, who would want a GFP green fluorescent person? And I was like, there would be people who would want.
Definitely be people lined up.
Yeah, I told them that, but I don't think I included that in the end in the draft. But,
ravers for sure.
Oh yeah.
Yeah, and then someone was talking about, could we use CRISPR to make a dragon? Could we use CRISPR to make a unicorn? And I think actually the unicorn idea probably would work because you could figure out the genes in animals that do have horns, and you could do a gain of function with CRISPR into.
Well, and horses and rhinos are super closely related.
Yeah, so I think we might see a unicorn. I don't know about a dragon, but so this is the kind of thing these are the kinds of discussions I was having with fellow scientists like 2 years ago. And then again, it would creep into the equation, like what could we do with people, and, there's some very serious things that we could do that would be beneficial, like tackling the cystic fibrosis mutation, Huntington's mutation, things like that. And there's real potential there. But what other people have educated me about is the power of embryo screening that we have now. There's this technology called pre-implantation genetic diagnosis, which is a big mouthful, or PGD, where you can take a family and bring them into a fertility clinic. They might have had Huntington's disease popping up in their family for generations, and you make 10 embryos, you screen them, you just focus on, say, the 5 that don't have the mutation. So when I've thrown that scenario out there to people who are real big, CRISPRing and human advocates, they don't really have a great answer for how, CRISPRing would be better than embryo screening. There's just rare instances where it might be better, like where both parents have a mutation, or, there's some complex genetic disorders where CRISPR might work better than screening. But screening is kind of boring, right? It's not as exciting
as actually manipulating.
Yeah, exactly, yeah.
And in a way, this is actually an interesting, perhaps, argument for those who are against even, blastocyst research. Where they've got these, what is it, the snowflakes?
The adoption of the frozen
embryo
babies.
adoption, because you can't froze, so everything goes into a freezer, because it's all murder, right? So hey, here's the option. You don't screen, you don't reject, you don't toss out, you don't murder your embryo, you fix it. And this is how we have. This could be that. I'm thinking in the policy, the horrible public debate, and how you pitch things to those people, but that might create an attractiveness to it.
It sounds like our population problem is going to get much worse.
Well, our population problem.
And that's a question.
Once we're microhumans, then we won't have a population problem. This will be this big. It'll be huge.
So, do you in the book you cover all of this discussion and all the possibilities, the pros and the cons, and cover it, like you said, in a fairly conservative manner, not going to the science fiction extremes, really. But what do you think it's going to take for society to come to an agreement? Like right now, not a moratorium, but just kind of an agreement that people aren't going to really use CRISPR on human embryos. But then in the UK, they just okayed some research on human embryos as long as they're disposed of after 7 days. So
yeah.
There are agreements, and there's this wiggly gray area. But what do you think it's going to take for humanity to come to an agreement? Or do you think we ever will? That because places like China have placed different values on life at different ages, that we're never going to come to an agreement.
Yeah, I kind of feel like we're probably never going to come to an agreement at a global level, just because there is so much diversity of opinion. And that was actually one of the fun things at the National Academy of Sciences meeting in December. They had representatives from different National Academy of Sciences from around the world, and one person from China, had their perspective. Another person, I think, from Nigeria had a different perspective, and so there's so much diversity. I think, there's going to be a diversity in how the science proceeds, and some people, some countries are going to be limited to just, modifying embryos for research, and others, I think, they'll go for it probably. And, just knowing all these years after having been in science for like 25 years, knowing a lot of scientists, I think there's probably a person out there who wants to be the first one to have ever made a designer baby, and
Sure.
Successfully.
Yeah.
Nobody wants to be the first to have a disastrous outcome. So this
Yeah, no one wants to be the first to have a disastrous outcome. And at this point in time, CRISPR is not accurate enough to be used.
Sorry, I just popped in because I lost my connection there.
Oh, we're following up with I'm sure there's plenty out there who want to be the first, but also there's who wants to be the first if it's unsuccessful, if it ends badly. Nobody wants to be that guy or gal.
Right, that's a big gamble, and especially if it ends badly, even in a country where things are kind of in a gray zone, you can imagine regulators throwing that person in jail or something,
That person, but then it'll affect the policy views of every nation whose witnessed this take place.
Exactly, and I think the other risk that I'm really worried about is that will negatively affect just CRISPR research in the lab on human cells, because there'll probably be some kind of backlash, like in my lab.
All research. Oh. We're having hangout issues this evening. We're getting kicked out right and left, unfortunately. We'll have to ask about.
And maybe it is the NSA because they've just come out against CRISPR. NSA.
Yeah, you are back. So people in your lab.
Oh, we're doing CRISPR on stem cells in a dish and cancer cells and things like that. Nothing, reproductive in terms of our intent, but you can see the public if a designer baby goes wrong, the CRISPR could become kind of a bad word, whereas now it's this fantastically exciting, positive thing. So I think by going too fast, we could kind of end up in trouble.
So the Chinese, there was a Chinese research team last year that published research having done research on human embryos to modify a gene using CRISPR-Cas9, and it wasn't very successful. And they published their research having done it, and everyone got up in arms just at the fact that they did it. But on the big media scene, nobody was really talking about the fact that it wasn't successful.
Yeah, it didn't go well. I think most of the human embryos they CRISPRified. They didn't have the exact gene they were targeting, corrected, and they had other off-target activity. They also had this interesting thing called chimerism, where some cells got CRISPRed, other cells didn't get CRISPRed. And if that were to happen in a human blastocyst that was implanted and became a person, you'd have a chimeric person. There's been cool stories on how we all might be a little bit of microchimeras, but if we're like a 50-50 chimera or something like that, that may not be such a good thing.
Yeah, it wouldn't necessarily get rid of the problem that you're trying to fix.
That's true, yeah. So it's one of these things, like, there's so much excitement, but I think there's a lot of risk too. So that was kind of why I wanted to write the book. The other thing is I wanted to learn more about the broader context, and so I went looking for books, and I didn't find much, that an average person who's educated could really get into. So that was kind of a motivating factor. I did read George Church's Regenesis and a bunch of other books. Frankenstein's Cat is a cool one. I'd recommend that on genetic modification of animals. So I hope to kind of add to the understanding and get people thinking more about this, and including the public, because the average person I would talk to, they were like, CRISPR, is that like a vegetable or something in your refrigerator?
In the fridge, yes.
Yeah, the CRISPR shelf. So So there's a lot of work to do to educate the public. We'll see. I'm interested in the meeting tomorrow at the National Academy of Sciences. Like, will the public actually get to talk, ask questions? Because at the first one in December, it didn't really happen. Yeah.
Right. Are they planning on doing many, like, regularly scheduled conversations that you know of?
Not that I know of. I think so. This is the second one that will come up tomorrow. I'm not aware of another one scheduled, but I know I've seen more CRISPR meetings kind of pop up around the country where, before it would just be the hardcore science. Now you're starting to see more about like social justice, more about international policies, because there's a lot of complexity on the legal sphere out there in different countries. And so I think we're getting a little deeper into it. And as I was writing it, I was really encouraged to see Jennifer Doudna come out and say she really led the charge, I think, in saying we need to think about this in a broader perspective. So I have to really commend her, because I think she's the one who really got everyone thinking, we got to think of this in the bigger picture. And I don't know, if it wasn't for her, we probably, there would be a lot less discussion going on.
And even though it goes against everything this show stands for and does on a weekly basis, sometimes I kind of think, gosh, wouldn't it be nice if you could just sort of sequester the news on something like this and just keep it in scientific hands for 5 years. Just let the scientists go and work and see what they come up with and see what they can do, and then bring it to the public like, oh, by the way, here's what we can do now. I mean, there's
that sounds pretty dangerous to me.
It is dangerous, but I'm actually much more terrified of the general public. I am absolutely terrified that policy can get written without any understanding of science than I am that science will fall into the hands of rampant madmen.
Why would you be worried about that, Justin?
Because I've seen it happen over and over again, and I'm getting tired of it. That's why.
People don't make decisions without knowing the real science, do they?
Nah.
Yeah. Nah. And as we move forward, we're also at a state where the research is happening. More and more people are working on CRISPR, Cas9, and CRISPR other genetic modification systems they're creating.
Modifications of CRISPR, yeah.
Modifications of CRISPR. The CRISPR technology itself is evolving at a rapid pace, and the work in the area is only bound to speed up. And so conversations do need to continue happening so that policy can be made in an informed way. And so thank you so much for writing your book. I hope a bunch of people take a look at it. GMO Sapiens. Are we really going to be? Is it we're gonna have new human species?
Maybe. Thanks for having me.
Thank you so much for joining us. Where can people find you online if they would like to find out more?
They can
just hear more from you.
Yeah, they can look for me on Twitter. I don't have a catchy name, unfortunately, but if you just look under Paul Knoepfler, you can find it. Or actually, I put a GMO Sapiens Twitter account up too.
Cool.
Or on my blog, ipsl.com. That's kind of a catchy one. And I did a TED Talk on all this stuff a few months ago too, so search for me on YouTube. Yeah.
Excellent.
Very cool. And TED Talks are nice and catchy and snappy, and will give everyone a good teaser for this as well, I'm sure. But thank you. We won't keep you
Kiki.
much longer. So great finally getting to talk with you and have you on the show.
All right, see you guys.
Excellent.
Thanks.
Thank you.
Have a wonderful night. Thank you
Thanks.
so much.
Bye-bye.
Bye. And everyone, that was Paul Knoepfler from UC Davis. He's written GMO Sapiens. We are going to take a short break, and then we're going to come back with science stories. We've got lots of science stories. I hope this first half of the show, though, really wet your whistle and got you thinking about all these issues. So we need to think about them and all of the ramifications. Good, bad, neutral. What's it going to do, huh? What you doing, Blair? You're hiding behind. Thinking
about my designer baby.
My designer baby is only going to have Gucci jeans.
Oh.
No. Maybe some others. I don't know. But I'll think about those designer jeans while we're taking our break. Stay tuned. More This Week in Science is coming in just a few moments.
Explain the things you heard with more than intuition. The line of reason shows the way.
I really love that song. That's Jake Mann who wrote that song, and I believe he had Max Hart working with him on drums. Great song off of an old TWIS music compilation from years back, but always a goodie that I enjoy playing. All right. Want to help TWIS out? We would appreciate your help. Really, truly. It would help us a lot if you supported us in one of several ways. We've got merchandise that you can purchase, wear, show your love for us, and also help us out financially in the buying of these things. Go to twis.org. We've got a Zazzle store. Click on that link. It'll take you to the store. You'll see hats, t-shirts, buttons, all sorts of things, mouse pads that have TWIS emblazoned all over them, so you can shout your love silently of TWIS to the world. If that's not your style, well, donations are pretty cool. So TWIS is also supported by your donations, just from people just like you. If you haven't donated before, please consider donating, because your donations help everything that we do. You make a difference in keeping this show going, getting us new equipment, making sure that our bandwidth is paid for. Everything that we do really is supported by you. The time that it takes us to do this show, the more support we have, the more time we are able to bring to what we do and what we make. $2, $5, $10, whatever you're able to give. We accept PayPal. We accept PayPal donations, and you go to twis.org. There are PayPal buttons all over the place. You can click, 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 click on those PayPal buttons, and hopefully that'll make it really easy for you to donate. Also, we are members of Patreon, so we've got a page up on the Patreon platform, Patreon, patreon.com/thisweekinscience, patreon.com/thisweekinscience, and you can choose your level of support. Through that interface, you get little goodies in return at each level. It's something different. And when you do that, you also get a warm, fuzzy feeling, because you know that every episode, whether it's $1 per episode, $4 a month, whatever it is, you're helping us. In this little tiny way, you're helping us make this show. You are our executive producers, really. But if you can't afford a donation, we totally understand that, and we can use your help in all sorts of ways. So if you're able to spread the word about TWIS, that is huge. So go to iTunes if you use iTunes as your mode of listening to the podcast. Leave a review on iTunes for us, and even rate other iTunes reviews. If they're helpful to you, well, rate it as a good review. That's really awesome. Tell your friends on social media about TWIS. I don't know, make a TWIS poster and put it on a telephone pole. I'm coming up with all sorts of different ideas here. But really spreading the news about TWIS would really help us out. Let people know that you enjoyed an interview. It made you think about something, and it wasn't something that you heard before. Let people know that you heard about this story or whatever that you're talking about around the water cooler at work because of TWIS in our conversation. It really helps when you let people know, because then people might check us out and they might become minions as well. And the family grows. It's amazing. I love this family. You guys are wonderful, each and every one of you. Thank you for your support. We really could not do this without you.
Growing real strong. Your cold disappeared after just 9 short days, all thanks to the words on the whole earth displays. Now due to the juices and pills and the creams, your body's lost toxins, whatever that means. You've stopped eating all of that sinister food. Your dinner tastes awful, so it's gotta be good. And still, you can't believe what a skeptic I am. I can't believe you believe in that shell. We disagree, but I still.
And we're back with more This Week in Science.
Hooah! That's right. Back in the science land. You know what I've got?
What do you got?
Slime! Well,
Slime.
I don't really actually have slime. I mean, maybe I do. It's been like raining and then drying up. There might be little pockets of slime in my backyard. But I've got a story about slime, and it's really cool.
Bring it.
So there are some bacteria that are able to phototaxi, which means they are able to perceive light somehow. They don't have eyes. They're little bacteria, and they know where the light is, and they move to the light. They're like, I will go into the light. I follow into the light. Why do we all want to go into the light? Well, maybe it all stems from this very basic mechanism that has been discovered in a species of cyanobacteria. Anyway, this is just so super cool. I don't even know where to begin. So these bacteria use kind of a micro-optics. And what happens is they use their cell wall as a lens, as a micro lens, like the lens of the eye. It's a little rounded, transparent surface, but it's able to focus directional light. So if there's light coming from the sun, some far-off point source, whatever it happens to be, it hits the front of the cell and then is focused to the opposite wall of the cell of the bacteria. So then the bacteria...
It's got a little mini projector thing going on there.
It's a little mini projector, exactly.
Huh.
So these researchers discovered using a bunch of different methods. They used this fluorescent, you were talking about GFP in the conversation with Paul Knoepfler, this fluorescent protein. They used that protein. They had a bunch of bacteria that they put this protein into so that it would, that protein would show up at the cell perimeter when the light was focused around it. And so they were actually able to see by the increase in fluorescence where the light was focusing on the cell walls of these bacteria. And so they were actually able to go, well, that's the direction the light is coming from, so there it is. That's okay. Fluorescence tells us that this is where it is. So they actually are able to get this physical basis. Now, they also found these little bacteria moving in the direction of the light. And so how do they do this? Well, it turns out they have they're phototactic little cilia or filaments that spread out. They've got them in little segments in their cell wall. And usually when there's no light or no directional light, they just, every 5 minutes or so, that little chunk that contains the motor proteins, it'll move to a different area of the cell wall. So the bacteria end up moving kind of randomly. So they don't really have any specific direction at all. But when the bacteria were exposed to light from a very specific direction, those motor proteins end up on the side of the wall opposite where the light is focusing. So it's basically on the side of the bacterium that the light is coming into. So you've got the.
And so this graphic you've got up.
I've got a video up of these bacteria moving toward the light.
And it's like the whole crowd heard the call free beer or something, and is all heading in one direction, quite uniformly, all heading that way. That's very cool.
Yeah, so basically you have light from a particular direction. It focuses on the other side of the cell wall. From there is a signaling cascade that involves ATP and some other proteins that turns on those motor proteins and says, those need to go to the other side opposite me, and you need to start moving. So light comes in, bounces off the back wall or focuses on the back wall. Motor proteins end up in the opposite side, and the feet of the bacteria move the bacterium along. They did another. I have another video here that we can show. Not great for the podcast audience, but I'll try and describe it as well as I can. They did another experiment to confirm this, and so by taking directional light that would get all the bacteria moving in one particular direction, they then made a focused laser beam, like focusing right down into the middle of the crowd. And hypothesizing, well, if this is, when it hits this bright focused light, hits the cell wall, that's going to tell the bacteria to go the other direction, because it'll be like the light coming in and then focusing, but it'll just be hitting the wall. So we've got this cool little video where the bacteria, they start moving along, and then the laser beam gets going. The laser beam's on, and if you can see, it's just this massive, it's a black background with these little balls of gray moving down toward the direction of the light. There's a red laser beam in the center of the screen, and as the bacteria run into it, they back up and they try to move away. And this focused light basically moves the motor proteins to the other side of the cell wall, so it makes the bacteria move in the other direction. But this finding shows, without a doubt, that these bacteria are sensing light, and they can see in a very minor degree.
And this also, for the just listening audience, basically looked like Space Invaders.
That's what I was going to say. Yeah, it looks like aliens.
The videos do look like
aliens. Yeah.
And the paper is available to the public. It's published on an open access journal. So if you're interested in taking a look at this, it's on the eLife Sciences journal, and so it's pretty cool. And so it's a very basic mechanism for light perception, detection, perception, and response, phototaxis. And we still use that basic mechanism in our own eyes with a lens.
See, and one of the things that people who don't believe in evolution often point to, which I think is hilarious, is the human eye. They love to point to the human eye and say that this thing that is so complex could not have evolved. It has to have been created. And
the eye is so simple. Our eye, the brain is complex. The eye is simple.
Yeah. So this is one of the common things that these people like to point to, which, first of all, the cephalopod eye and the human eye are actually, they have a lot in common. So the fact that they're so far removed means actually, hey, convergent evolution, hello. But then on top of this, bacteria have the building blocks for our eye. This is great.
Yep. Mm-hmm. It is very great. So this is, I think it's a really fun, just cool study, and how neat to learn something about these little tiny simple creatures that is kind of the basis for something that we think of as very complex.
Exactly. Yeah, it's so interesting to see. Now, remind me, I was looking at this article earlier. Is the image upside down like in our eye? Or is it right side up?
I don't know if it's an image per se.
Well, not the image, but the light source. Is it getting flipped? I want to say
it would be flipped.
Yeah,
because it's a micro lens. It would be.
So this is just
flipped.
like a tiny eyeball.
It's like it's like their entire being is a tiny eyeball.
Mhm. Yep.
It's so
and
cool.
The inside of the cell, the inside of that barrier to everything else, is like the back of our eye, and it can, wherever it is, can take in the view from all around. It's a giant 360-degree projection theater inside of a bacterium.
Very cool.
So cool. I love it.
What's up, Justin? Tell me a story.
So for years now, I've been telling you about the feline-found protozoan parasite Toxoplasma gondii.
Yes.
Past studies have not only illustrated the parasite's ability to blind babies and alter human behavior, but that it specifically created an attraction to cat urine in rats. That the parasite, which only reproduces in cats, would make rats specifically attracted to the scent of its greatest predator, and this parasite's favorite host is likely no accident. We have even speculated here, we being mostly me, probably only me, that this could be an explanation to a particular type of toxo-infected population known unscientifically as the crazy cat lady. As though the parasite were driving the cat hoarding behavior in order to gather enough predators to take down the larger human prey. Okay.
Scientifically, it has been linked to erratic behavior and some other disorders as well.
Yeah, so it's personality changes, delayed reactions, long-term concentration issues, also forms of schizophrenia, which could be cured, and that's the cat lady. It creates guilt issues, specifically guilt issues in women, which is part of what leads to the crazy cat lady.
Right.
Not in Sunday.
Right. And a couple times this year, too, sorry to interrupt, but a couple times earlier this year, we found it in other vertebrates for the first time, like otters. And I want to say there's something else, too, but we didn't see any behavior changes yet in these guys.
Right. And largely, it sort of makes sense, the rat-cat interplay of a rat being attracted to cat urine, because then the rat that's infected gets devoured by the cat predator, and the parasite goes back into the cat, whereas the only place it reproduces, and then it goes back out into the world again, where if it ends up in an otter, it's kind of hard to see how it's going to end up in a cat. So it's not normally probably even afraid of cat urine. So now no longer being afraid wouldn't do anything. So it would have unusual effects. This is sort of what they've thought is going on in humans' peculiar behavior and personality changes and the like, because we don't have a present cat predator, right? We're not running from our domestic cats as though they might eat us. So it still is attempting to make some modifications to behavior, but that we don't have a natural inborn instinct to fear cat urine, it doesn't really seem to do what it does in the rat. Anyway, this is the news story. This is out of French researchers, large institution in France, which is conducting this research. Chimpanzees infected with T. gondii are found with a fondness for leopard pee. Like the domestic cat to the rat, the leopard is a top predator for the chimpanzee. Most interestingly in this, the effect was not universal to big cats. The infected chimps were still averse to the urinary disperse of lions and tigers. So you have chimpanzees. They fear the smell of big cat pee because they know these are predators. They get infected and they become specifically attuned and become fond even of the scent of leopard pee. And these are chimpanzees who aren't normally exposed to lions and tigers, and so this is this wild dynamic, suggesting that the parasitic behavior affect is specifically linked to a particular predator. In humans who have avoided this top feline predator for some time, there are still behavioral personality changes that take place, like I was saying, but there's no top predator that it seems to be specifically making us fond of, because we haven't had one for so long. We can't identify in our brain, I guess, or that link is that recirculation of it's in here, it's making modifications to behavior. Now we're back in the host in this sort of feedback thing where it's like, aha, this is the predator, and reinforces either through epigenetic or natural selection to make us fond of a specific predator P. So if this isn't simply a universal effect of toxo-infection, but something that evolves over time that adjusts to changing environments and different predators and prey. So we have a maintaining of strategy from chimp versus leopard to house cat versus field mouse. This thing can sort of adjust which predator-prey relationship is being affected. Perhaps my cat lady speculation example of an evolving strategy specific to an intermediary host isn't that far off, and this is an attempt to bring back a full circle within this new environment of the domestic house cat, looking for something that in its environment to affect, and if it's a cat that's being hoarded, it only has humans as the possible potential new prey to attract to the predator. So that's the story. The more we learn about Toxo, the more diverse its abilities seem to be.
I think the key that we've found here is that it's not diverse, but this is still the predator-prey interaction. The parasite is honing in on the predator-prey relationship, where monkey or chimp, sorry for those of you who are ape, want to be specific. Primate, yes.
Primate.
That the prey species is being controlled to go. The prey species matters. If it is getting, we do not have a specific predator.
That's a feline.
That is a feline, and that is important to our survival evolutionarily. And because this has to be happening in a large enough population. It has to be hitting a large enough percentage of the population to make this worthwhile for it to work.
Right. So I think the next thing to do is look at something like a lion or a tiger and look at their main prey and see if that
main prey. Good one.
I didn't even mean to do it, but okay.
What? What did I? Oh, because the lion has.
There's a lion.
Yeah. Look at their main prey and see that see if there is something going on there.
Do wildebeests.
But what I do, I mean, I think this is amazing because this isn't a universal thing though. Then this isn't. We can't just say it just makes it attracted to felines. It's something very specific that you can then start to drill down on about what it is different in, I guess, leopard pee versus tiger pee that's creating the reaction, the attraction. Very interesting.
Totally interesting. Super interesting. I mean, it's just to find it in other species working in that same exact way. Let's keep looking.
It says research needs to be done to find out if Toxo triggers oxytocin rushes when humans see kittens. I think that's slightly unfair, though, because I have children who seem to get that rush over every form of baby animal picture.
Yeah, so we've talked before about how on the show the physical properties of a mammal baby are specifically geared to have a oxytocin or some sort of parental hormone rush.
Yeah, I had both of my daughters earlier today, just hours before the show. We were looking at baby animal photos on the Google, and it was just a cacophony of every animal was evoking
It'll do that.
I called my insurance company today, just trying to get immunization records for my child. I told her that my child was going to be coming into kindergarten in the fall, and the woman who helped said, "Aw." I got an immediate "aw." She didn't know my child. I just said my child was 5 and had to go to kindergarten, and she went, "Aw." So this happens.
Yes.
Babies.
Baby animals. Just the thought of any baby animal. Aw. How many people are going, "Aw," right now as they're listening? Do you know what time it is?
I do believe it is about time for Blair's Animal Corner.
Those are creatures, great and small. 5 big, little pet, no pet at all. Want to hear about animals?
she's your girl. Except for giant pandas and squirrels. And
What you got, Blair?
Oh my gosh, well, we were just talking about baby animals. What do you need to get baby animals?
Adoption papers? No. Money?
No.
Backyard.
Courtship, for
Courtship.
starters.
Or sex?
Yes, we're getting there. We're going to
Okay.
start with the courtship part.
Okay.
So we're going to first talk about chimps. Now, chimps, we've already talked about a little bit today, and about how the whole toxoplasmosis thing. But they also have a lot of things in common with us in terms of social strata and social kind of norms. And one of the things that they do is when they are engaged romantically, they will do a lot of grooming behavior on each other. This is a bonding behavior we see in pretty much all primates. They'll groom each other to kind of bond. So one interesting thing related to that is that by studying chimps in the wild, so these aren't lab chimps, these aren't chimps that are being manipulated in any way, these are 100% wild chimps being observed, the grooming behavior is not entirely dependent on the relationship they have with each other. It is also dependent on who's watching.
Oh.
Yes.
Oh, so if maybe a little girlfriend on the side is watching, or if, I don't know, a competitive male is watching, it's going to change the likelihood that that ape is going to start. Yeah.
Yeah, so
chill.
basically it's about who's watching, if they could potentially be mates, and therefore they don't want to show attachment. They don't want to have their PDA, right, their public displays of affection, on this other chimp. So they mostly saw this with males too, of course, is that the males were less likely to reciprocate grooming or even begin grooming, or they would finish grooming early if there were particular bystanders around. So, yeah. Chimps, they're just like us.
Just like us.
Okay.
Got you grooming by that old tree? It wasn't me.
Now, oh my god.
Picking bugs right up in the foliage? It wasn't me.
Oh my god, that's fantastic. So after the courtship, then comes the copulation, right? Now, the last step before the copulation, depending on what kind of animal you are, sometimes you need to cozy up close to that female. If you're a male, you need to convince her to stick around, let you do what you're going to do.
Baby, it's cold outside.
And as far as invertebrates goes, a lot of them need to sneak up on their females, but others, they actually have to convince them to hang out. And fruit flies, they actually sing to their females almost like a bird does. They sing, or they purr, or whatever you want to call it. They actually make these two different sounds, and I don't know if Kiki is going to be able to pull those up, perhaps, from the show notes, but there's a couple different types of sounds that these flies will make. Now, what's really interesting about this new study is that they can actually adjust the amplitude, they can adjust how loud they are based on how far away the female is. To give you a little bit of an idea, in order for us to hear the sounds that the fruit flies are making, these sweet, dulcet tones, the researchers had to record them on sensitive microphones, amplify them more than 1 million times in order for us to hear it. So one of the sounds that they make sounds like a whine, and the other one sounds like a pulse, almost like a purr. And these two sounds together are what convince a female to stick around long enough for the male to approach and then copulate. And they can adjust how loud they are based on how far away the female is, which is something we've only ever seen really in apes and in birds, is that they will actually adjust their acoustics based on how far away the female is. And by doing that, they can actually maintain the song longer, which might be the difference between getting the girl and not.
I'm having trouble getting this song up.
Okay.
Unfortunately, but I love the idea. It'll make me think of fruit flies entirely differently
Yes.
as I think of them purring
Yes.
and maybe scream purring.
It's kind of like a brrr, and then the other one is oh man, it's more like a brrr.
Okay, I'm going to try and play this through my headphones. Just don't talk for a second.
Okay.
And then
So that was the screamy one. Yeah, so that's the purry one. Yeah, exactly. And so they can adjust that, even though it's a million times quieter than something we can hear, they can adjust it enough to make a difference in their energy requirements. Pretty fantastic.
Dar in the chat room. Whiny males are not attractive.
You know what? Persistence pays off sometimes.
Yep.
Speaking of which, here you go, guys. This
Nobody
is
ever goes out
No,
with
no,
me.
no, no, no. No, it's
Come
not.
out with
Hey,
me.
Justin, I'm not gonna. I'm not thinking of this as whiny males with their purring or the purr screaming. I'm thinking of Lloyd Dobler with that boombox at the end of that movie, holding up the boombox outside the girl's window.
persistence. See?
Persistence, playing that song.
Yeah. That's exactly it.
Yes.
Now,
Okay.
I want to get to my favorite story of the year thus far, perhaps, nay, the century.
Wow. This is so much build up. I'm afraid to listen.
And the internet's going to cut out any second, I know.
I feel like it's going to blow my mind.
But
and I won't be able to function in society anymore.
there is a scientist, a doctoral candidate in biology named Elizabeth Droege Young. She and I know we are kindred spirits because she, since she was a little girl watching Mutual of Omaha's Wild Kingdom, has been fascinated with courtship. And more recently, she has been fascinated by the mysteries and motivations behind sexual selection. In particular, she has been very interested in promiscuity among female red flower beetles. This is weird because during the course of a day, female red flower beetles would mate multiple times, sometimes multiple times in an hour throughout the day, sometimes coercing males that were no longer interested into mating. This is bizarre. This is beyond bizarre because these animals, the males, deliver enough sperm in one copulation for females to lay eggs for months. So why on earth?
Oh, why on earth?
And
why
yes,
on earth
yes,
would they be?
the internet's mind was blown by the
I knew this was going to happen.
Why on earth? And
We're all
she
hanging with
happened-
great anticipation. And she phrases again.
on her favorite story, she predicted that this was would happen. This is the problem. So the
Why on earth?
It's the buildup. The buildup broke the internet.
I'll
So
say it
why-
again.
Why on
I'm
earth do
so
these
filled with
females
anticipation.
need so much sperm, you guys? Why? Why would they? Well, so Elizabeth Droege Young had a few ideas in mind. She thought either the sperm provides moisture or nutrients, which we've talked about a lot on the show, or proteins that support egg laying, some sort of chemical signal perhaps, or they just need more sperm than we thought. So those are her 4 ideas. Do you guys have any ideas? Any guesses?
I like the nutritional one.
Nutrition, maybe.
The second thought was girls just gotta have it.
Sure. Turns out it's for the moisture. So these females need liquid so bad. They're from a moist environment, but now they're often found in drier environments like grain storage facilities. They get hydration through mating. The seminal fluid that they get is hydration enough. It's motivation enough for them to mate over and over and over. And the benefit is not reciprocal. When female fitness...
No.
It never is. How often is it? Oh, we made her quiet again. It never is. The males never get as much of a benefit as the females. The males end up with the benefit of their genes being passed on to the next generation.
Yeah, so the males, their fitness actually drops off when they get to this high frequency of mating, but the males, again, their genetic material is cheap. They kind of just want to spread it around. So I understand why the males could still be coerced. But the females, they're getting hydration. And yes, I'm going to make the terrible joke, but this is real, guys. This brings a whole new meaning to somebody being thirsty.
Funkaman in the chat room has a pretty funny one-liner. Hey, baby, can I buy you a drink? It works for this red flower beetle. That's for sure.
Actually, in this scenario, wouldn't it be the female beetle being like, "Hey, buy me a drink. Come on, buy me that
Buy
drink.
me a drink. Yes, that's exactly what that is.
It's like, nah, look, I just want to go to bed, and I'm tired, and I'm so thirsty myself. I gotta go find water. Okay, one more time.
Yeah. So, go ahead.
I was just going to say, what an interesting tactic for hydration. Like that this would become, that the males would conserve or preserve the water in their semen, and that the females would then use that as opposed to going elsewhere to find water.
Mm-hmm. Yeah, and so this has two really big implications. The first is that environment can influence mating systems in ways we never thought. So this is a species that, when we look at them in a moister environment, you don't see this as much. So in a dry environment, totally changes the dynamic and the influences. There's huge influences on mating in a new environment. The second part of this that I think is really interesting is we already have been looking at reproductive packets, if you will, from males, giving genetic material and giving nutrients. We know about that. Spiders, cephalopods, there's others. But this means that there's a whole extra realm of possibility that we never thought about. There's so many, it's so complex. Sex is so complex, guys. Even in invertebrates, especially in invertebrates. I love it. It's amazing. It's like the gift that keeps on giving. Happy Valentine's Day.
Happy Valentine's Day. Thank you for that beetly love story.
Oh my gosh, I love it.
Love, beetle style.
Yep. I need to buy that researcher a drink.
Absolutely. That would be fun. So, seasonal brain changes. Oh, wait, I've gotten way ahead of myself. Justin! It's your turn.
It is. Is it?
Yes, it's your turn.
Okay, this is research published in 2012 and reported here suggested that possible early human ancestors had lived on a diverse woodland diet, including hard foods mixed in with tree bark, fruit, leaves, plant products, nuts maybe. New research, though, by an international team of researchers shows that Australopithecus sediba didn't have the jaw or tooth structure necessary to exist on a steady diet of hard foods. Most of the Australopiths had amazing adaptation in their jaws. They had big, strong, fierce teeth and jaw that allowed them to crunch up bark and eat pretty much anything. They could survive on that sort of, not just the paleo diet, but they could be a survivor. They could go rip bark off a tree, eat that, get nutrients off of that, no problem. They had very high force. So, but this is Australopithecus sebida, thought by some researchers to lie very near the ancestry of Homo, which is our lineage. So which is it's sort of a smaller kind of a Australopithecus, and that means we're talking like 2-3 million years ago. This is Australopithecus Setibus 2 million years ago. Australopithecus goes back even further, like 3-4 million years.
Right.
This one is kind of interesting because it's sort of the fact what they did is they put the jaw structure into a machine that they usually use to test like automotive parts to see integrity of what sort of forces it could handle, and it found that if it failed pretty well on that sort of bark diet, the hard food diet. It would basically dislocate the jaw if it attempted to eat this kind of food on any sort of consistent basis, which is actually what modern humans are more like. We also have limitations in our biting force that is maybe even more so than Setiba. So that it shows that even though this study wasn't specifically looking to see if this was the branch that we were most related to, this is a very interesting connection that we now have because it is showing that against what we were sort of thinking based on diet that we found residues and remnants of, it could probably eat about the same kind of foods that we can eat today.
Jawbreakers have always been jawbreakers.
They've always been difficult. Yeah, and it's sort of also interesting because it sort of does make you think that, or at least made me speculate that maybe an element of tool use derived from the fact that we couldn't masticate just anything. If you need nutrients. If you need nutrients from bark, but you can't chew it, you need to take a rock and smash it up really good first, and then ingest it, right? So there may actually be a link from advancements in tool use to having slack-jawed ancestors.
Nice. Slack-jawed ancestors, not necessarily slacking off.
No, having to work harder actually.
Working hard. Just like people trying to figure out what's going on in space. Right?
Mm-hmm.
We're on a rock in space, but we're not out in space, and we can't see everything, and we don't know everything, so it's like, what is going on out there? We have to figure it all out. Well,
we're stuck going in a circle all the time.
Yeah, and
billions of galaxies in the known universe. The galaxy that we're in, we are actually in a rather rural part of. So,
and
it's hard to see stuff from there.
And the rest of our galaxy, the Milky Way galaxy, gets in the way of our view of stuff behind it.
Oh yeah. What's behind that way? There's
nothing.
Too much noise pollution over there.
There's noise and light pollution, right? So for a long time we've just been going, okay, we know there's this place over there, this big region that it's sucking everything toward it. We're going to call it the Great Attractor because everything seems to be gravitationally attracted to it. So, researchers are using CSIRO's radio telescope, the park's radio telescope that has this new innovative receiver attached to it that allowed them to pretty much get a view through all the noise and light pollution and focus in on what is beyond the Milky Way. And it kind of makes sense. There's some other big galaxies out there beyond the Milky Way, between us and the Great Attractor. So why is the Milky Way galaxy getting sucked in that direction? Why is our local group getting sucked in that direction? Because there's more big galaxies there that account for a lot of gravitational mass that we didn't know was there before. So it could be the Great Attractor is pulling on those things that are attracting us, and it's kind of like a big tug-of-war. But we didn't know it before because we couldn't see them. And we just thought it was like this big blank spot. Anyway. 883 galaxies, a third of which had never been seen before. Yeah. So all that gravitational mass, important in the calculations. And then another group, they've been looking at our solar system, and they're like, okay, let's try and figure out this solar system development. How did it happen? How did Earth end up where it is? How did everything end up where it is? And there's just been this idea, this hypothesis for a long time, that Jupiter, the giantest in our solar system, has been an attractor for things outside, coming in from outside the solar system, comets, the odd stray rock going through, that Jupiter attracts them because of its giant gravitational mass. And
318 times the mass of the Earth.
Yeah.
Pulling everything into it.
Right. It's like we imagine it as this big black hole in our solar system.
Yeah.
Well, researchers recently put together a new, they were at NASA Jet Propulsion Laboratory in Pasadena. They published in Astrobiology a new simulation in which they tried to look at tens of thousands of particles going through the gaps in between those big planets, those gas giants, for up to about 100 million years. And their simulations don't match up with that hypothesis of Jupiter as the protector of the inner planets. In fact, the simulations show that Jupiter and Saturn are like, here, catch this soccer ball. And they're just kicking stuff into the inner solar system, into the path of the Earth. And that we may have Jupiter and Saturn and these other big gas giants to thank for all of the stuff in the inner solar system that occasionally threatens life.
Gosh, thanks a lot, Jupiter.
Yeah. Thought you were helping. Turned out no. Jerks.
Those big bullies, those big gas giant bullies in the outer solar system, they're just jerks.
I can go blow some noxious gas over there or something.
Yeah. All right. End of the show, short things.
I've got one. I gotta find it though.
Okay.
So this is that story that this is so strange. Scientists at the National Institute of Health have identified a genetic mutation responsible for a rare form of inherited hives that is induced by vibration. Urticaria experience exaggerated version of normal cellular response to vibration. So you can be like on a bus, I guess, for too long.
A motorcycle.
Movie.
Motorcycle. Break out in some kind of hives. I've never heard of an allergic symptoms to vibrations before. You both of you seem like you've heard of this. You know this exists.
No, before reading this story, I saw this story late last week, and before reading it, I had no idea either. This is.
In addition to the itchy red welts at the site of vibration on the skin, people with vibratory urticaria also sometimes experience flushing, headaches, fatigue, blurry vision, or a metallic taste in the mouth. Symptoms usually disappear within an hour. Those affected may experience several episodes per day.
Which would be pretty obnoxious.
It's like every time you get in a car, right?
Yeah.
Yep.
Whoa. That's one of those things I would not have known was even possible to exist. But yeah, they've narrowed it down to a genetic mutation that somehow is responsible or involved or indicates that this will be present.
Well, load up the CRISPR. We'll get rid of it.
That's right. That's
there
what
you
I was
go.
thinking. Perfect candidate.
There you go.
Perfect candidate. Interesting new study found that people's brain activity changes annually throughout the year. So your brain works differently in the summer than it does in the winter. which
Makes
is
sense.
it does make sense. We talk about people talk about seasonal affective disorder, they talk about spring fever, they talk about, just there are lots of different ways people refer to how they feel during different seasons. But this is the first study that people have actually undertaken to look at the brain under magnetic resonance imaging at different times of year, and also to have people do cognitive tests. And so the researchers found that there's a difference in brain activation for different times of the year. So different areas of the brain were active in particular times of the year. Areas involved in working memory, so your ability to kind of remember stuff, keep focused, keep it going, hit peak performance around the autumn equinox. Sustained attention, though, crested around the summer solstice. So they found that there is a shift to the way you think, or there wasn't necessarily a difference in cognition or what people were able to do, but in the areas of it seems like different areas of the brain are compensating and picking up slack at different times of the year. And so, yeah, for areas of the brain linked to sustained attention, the thalamus, etc., activity was peaking at the height of the summer and dipping in the winter. Kind of the time of the year that you want to go into hibernation and not pay attention to things.
So there was, and I don't know where I've heard this, and so this is totally unsourced information. But I do recall hearing it that most wars are started in like the hottest later part of summer, as a for instance, and whether there's actual truth to that or not, it would make sense, I suppose, if somebody was. If people actually think differently and are more willing to engage in a long-term thing like war during the summer than the winter. But that's probably has other things to do.
I'm wondering if this has to do with the food available at all. We still do have seasonal changes in what we eat, and I'm just wondering if you're eating more fresh food, you're eating a more balanced diet when everything's growing, and then in the winter you eat a lot of fatty foods, a lot of preserved foods, nutrients are different, go down, more carbohydrates, exactly. Also, people tend to drink more when it's cold. I don't know.
Yeah, that's an interesting question. No, that's not anything that they controlled for. So, yeah. Interesting questions. I don't know. But they did find this difference. And so, yes, it was a very small study, 28 volunteers, evenly split by gender. So this was across genders. But still, worth further looking, worth further investigation.
I do hear also that people tend to make more purchases very near towards the end of the year. So maybe there's something to this.
Yeah, additionally, other seasonal changes that were found to occur in recent research, bears have changes in their gut bacteria between the winter and the summer. So researchers looked at bear poo to discover what kind of bacteria was contained in the poo as a proxy for what was going on in the gut of the bears. And they looked at, and they transplanted these bacteria into mice. And so they found that potentially bacteria is what is something that helps bears hibernate. The mice that they gave summer bear bacteria to ended up putting on weight and getting fatter. And the mice with winter bear bacteria lost weight and got a little bit slimmer. But everyone stayed metabolically healthy. Everyone was good. It wasn't like all of a sudden the mice just got skinny. They just, yeah. So anyway, bears' microbiomes, helping them out. Don't go looking for bear poop in the woods if you're trying to, find a new diet. This is not the way to do it. And my last story, new condoms for love, made from grass.
Like grass or like grass?
Like grass from Australia. Not like grass, but like grass.
Wait, I thought you were talking about grass.
That green grass grows all around and around, and the green grass grows all around.
All around, you know what?
Australian native.
Just happened.
Oh no! Australian native spinifex grass, and this is grass that Aboriginal peoples have been using as a tacky substance to help put arrowheads on the front of their arrows, spearheads on the front of their spears. But anyway, researchers are working with the native people to create a method of taking nanocellulose out of the grass, from the grass. So cellulose, but nano-sized. And then they're using that as an additive in latex. And they say that they're going to be able to make a condom that is as thin as a hair. So
That's pretty thin.
Hair-thin condoms that are just as strong as the condoms that are currently in use.
So they're still going to prevent pregnancy and block disease, is what they're saying. Both
That's
of those.
what they're saying, yes.
That is...
That they
wow.
would be thinner, which is better.
Yes.
But
more people will use them, definitely.
People will use them.
Are they?
And they will be better.
Are they more durable? Are they stretchy enough?
Yes, so they're working on that. So a quote from the researchers. We tested our latex formulation on a commercial dipping line in the United States and conducted a burst test that inflates condoms and measures the volume and pressure. And on average got a performance increase of 20% in pressure and 40% in volume compared to the commercial latex control sample.
Nice.
With a little more refinement, I think we can engineer a latex condom that's about 30% thinner, will still pass all the standards, and with more process optimization work, we'll be able to make devices even thinner than this.
So that sounds like a good test. Of course, we're not trying to create a better water balloon, though. I mean, this isn't exactly what takes place.
Well, it's not that far removed, really. I mean,
I think it is. I don't know that you're creating like balloon animals at this. It's more friction test than the rest of these sorts of things and elasticity. But yeah, world with a better condom.
And the great thing about this is the researchers are working with the Aboriginal people to make sure that that their heritage is maintained, and they basically get some financial royalties back from this work. So this could end up helping out Aboriginal peoples in Australia.
I think I also read too that this research could lead to thinner and better surgical gloves.
Surgical gloves. I mean, it would be a latex additive, so it would make anything made with latex potentially could be made with thinner and stronger.
Yeah, which would be great because if anyone has ever done that experiment they have high school kids do now, where you wear latex gloves for like a whole day, and you're supposed to feel what it's like to have sensory deprivation all day.
Welcome to working in a lab.
Right. So there's that, but it definitely does dull your senses a little bit. And if you're doing something that requires so much dexterity and precision as intensive surgery, having a thinner glove could be a huge advancement.
Yep. Absolutely.
Especially if they're harder to break too. That's also better for the doctors.
And then it won't be as I've heard described like taking a shower with your boots on.
I hope that no one would describe This Week in Science in that way. Are we at the end of our hour?
I believe we have reached
our hour.
The end of our definition of how much time it takes to fill an hour.
Yes. Did you know that on your TWIS watch, an hour is about an hour and 40 minutes?
We're on a different planet.
We are. Oh, this is what I was going to tell you, though. But good news, I was informed that at least for the month until the end of March, KDVS needs an hour and a half of my time. So We're doing great.
Hashtag
So-
winning.
Wait, this was the February short show month.
Yeah,
Remember?
but now
We were
it's
gonna-
not because
But-
KDVS needs us for an hour and a half.
Yeah.
Yep.
Oh, perfect.
There we go.
Relatively done.
All right,
Everything's
everybody.
coming up, TWIS.
Everything. I love it. I love it. I want to give shout outs, y'all. I want to give shout outs to all of our supporters on Patreon. Thank you so much to Kevin Parachan, John Rataswamy, Steve DeBell, Patrick O'Keefe, Jason Schneiderman, Rudy Garcia, Gerald Sorrells, Greg Guthman, Dave Neighbor, Jason Dozier, Matthew Litwin, Eric Knapp, Jason Roberts, Patrick Cohn, Richard Onomus, KDWB, Byron Lee, EO, Bob Calder, Jared Lysette, Ulysses Adkins, Brian Condren, Jake Jones, Trader84, Kati Volk, Edvardus Rumkus, Brian Hedrick, Cassie Lester, Sarah Chavez, Stephen Soroyak, Layla, Shane and Tara Ginsburg, Marshall Clark, Charlene Davidson Henry, Don Kamarechka, Larry Garcia, Randy Mazuka, Ed Dyer, Tony Steele, Dave Friedel, Craig Landon, Daryl Lambert, Dave Wiley, Robert Aston, Andrew Dolinger, Sylvan Westby, Artyom, Michael Perez, Shuwada, Stephen B., Dave Wilkinson, Steve Mashinsky, Rodney Lewis, Braxton Howard, Phil Nadeau, Rick Ramus, Salgood Sam, Matt Sutter, Emma Grenier, Philip Shane, James Dobson, Kurt Larson, Stefan Insam, Michael George, Russell Jensen, Mountain Sloth, Jim Drapeau, Tara Payne, Alex Wilson, John Maloney, Jason Olds, James Noah Wiles, Paul West, Alec Doty, Illuma Lama, Joe Wheeler, Dougal Campbell, Craig Porter, Adam Mishkan, Aaron Luthen, Marjorie, Paul Stanton, David Simmerly, Tyler Harrison, Ben Rotheg, Colombo Ahmed, and Gary Swinsberg. Thank you for all your support on Patreon. If you're interested in supporting us, you can find information at patreon.com/thisweekinscience. Also remember that you can help us out simply by telling your friends about TWIS. On next week's show, we will know whether or not gravitational waves have been discovered. There's an announcement tomorrow. They're announcing some kind of research. Rumor mills have been winding up and going crazy on the interwebs all week long. Tomorrow, Thursday, the 11th, there's an announcement. So next week's TWIS, we will talk about gravity waves or no gravity waves.
And what's really interesting about this is that there's been no gravity waves for so long, so why make an announcement that we still haven't found them?
Yeah, that's what I was wondering.
NASA
Just so
does,
you know,
NASA does stuff
still
like that all the
nothing.
time.
still not, we're looking, but still nothing has been found. It would be really weird to do this
You guys, I
announcement.
have not yet found a Pegasus. I just wanted you to know.
Also that Grail and the Fountain of Youth also have
Also
not been.
not
Also,
found.
leprechauns. Turns out, not a thing.
Not a thing. Oh my goodness. Once again, next week we'll be broadcasting live online at 8 p.m. Pacific time on twist.org/live. You can watch and join our chat room. Do it. It's fun in there. There's great people in our chat room having fun watching the show live. But if you can't, don't worry if you can't make it. You can find our past episodes at twist.org/YouTube or just twist.org.
Thank you for enjoying the show. TWIS is also available as a podcast. Just Google This Week in Science in your iTunes directory, or if you have one of those mobile-type devices, you can look for TWIS, the number 4, Droid app in your Android marketplace, or simply This Week in Science in anything Apple marketplacey.
For more information on anything you've heard here today, show notes will be available on our website. That's www.twist.org, where you can also make comments and start conversations with the hosts and other listeners.
Yes. Or you can contact us directly. Email Kirsten at thisweekinscience.com, Justin at twistminion@gmail.com, or Blair at blairbaz@twist.org. Just be sure to put TWIS, TWIS, somewhere in your subject line, or your email will be spam filtered into oblivion. You can also ping us on the Twitter, where we are at TwistScience, at Dr. Kiki, at JacksonFly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes to you in the night, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from today's show, remember,
It's all in your head.
This Week in Science. This Week in Science. This Week in Science. this week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. This week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just better understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. Jeopardy. And This Week in Science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got a laundry list of items I want to address, from stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. But how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say. And if you've learned anything from the words that we've said, then please just remember it's all in your head. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.
And now is the time for the after show, when the rest of everyone have gone somewhere else.
No, I'm here.
There you are, behind your spider.
I'm just showing everyone my Valentine from the National Park Service.
So cute.
Yeah. It's actually from the Golden Gate National Parks.
What a cute little spider.
Yeah.
I love little nature spider things. I got pop-pops. Pop, 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 pop.
Ooh. I only have eyes for you.
This is not the time to be playing with pop-pops.
Nope. No. Not when your child is sleeping, for sure.
You got it. So, I've realized that I need a flash drive with room on it for my presentation tomorrow and my presentation Friday. I need to put them on a flash drive so I have them physically in hand. And the problem is, I think I've given all my flash drives to my husband and I never get them back.
You might have to go to Walgreens and buy one for like $5.
I know. It's like my pens. Where'd all my pen? Where'd my pen go? What pen? My pen. My flash drive. Where are my flash drives?
When you get married, everything's collectively owned. You know that. There is no more me. There is only us.
I want my flash drives. There we go.
Fungo Man says, Bacteria Valentine after tonight's show. I only am an eye for you.
Nice. Very nice.
That's great. I was thinking about if I had had enough time making a series of TWIS Valentines that were based on TWIS stories that we did, like I love you so much I want to stab myself in the head with my own penis. Is that not how love works? Maybe I don't understand.
I don't think people would think that's nice. I think
Or,
it's nice.
I'll let you stab me through my body wall any day.
Oh, I
I'm
love you so
thirsty.
much. I'm ready for some trauma.
Yeah, I'm thirsty for your love juice.
I'm thirsty for your love. Oh my.
I'll wear a grass condom for you. Or at least I'll tell you I'm wearing an ultra thin grass condom.
It's no. It's the new kind of condom. It's so thin, neither of us can.
Oh no, I swear I'm wearing it. You just can't tell. It's made out of grass or something. Yeah, that's it. Yeah. Oh my god. Oh.
I'm crawling around
It's too much.
the floor.
It's too much. I can't handle it. It's too much. Oh. Go, this show got me.
What's in there? That's a big thing.
Oh. You mow it and water it. Nice day.
What's it? Did she go away again? Oh, I got posters. Posters are here.
Yeah, she's frozen. In a reverse live long and prosper.
I think I have some cool posters in here.
I don't know how much longer I'm gonna last, guys.
I know.
I keep getting kicked out.
Yeah.
Which is obnoxious.
How come neither of you ever got kicked out?
I don't know. It was
Chia.
we were the first.
Chia condoms.
We were the first two in, so I'm guessing it was something to do with some Google Hangouts limits or
I
something.
don't think it's limits. I don't think that they're kicking people out intentionally. But I don't know. I mean, internet.
Some accidental limit, a glitch.
Something glitchy has been going on.
It's such a bummer too, because I'm usually in way before Justin, but tonight,
Yeah.
darn it.
Actually, I thought I wasn't gonna make it again. Right away. It was popping up all these like error. This page will not load.
Danger, Will Robinson.
Run! Go outside of your home. Leave now.
I'm telling you, solar flares.
It was really, but then when I tried it again, it worked, and I don't know. I don't understand. It's the thing I will never understand about computer stuff is how something will not work and then it will work, and you've done nothing different.
Maybe I have a flash drive on my keychain. Thank you, Dave Friedel. I will have to go look at my keychain. That's an idea. It's
Wait.
probably full if I do.
You know what always works? Duct tape.
I cannot put my presentation on duct tape.
Nicely done.
You and your duct tape and your knife. Plastic
There's one on
cutlery.
that side, and then there's one on this side. But see, I was very careful to do them below where the normal plane of vision is on the show. See?
Yeah, no, very well done.
Dave, no more duct tape. What's wrong? What you got against duct tape, Dave?
I at first had assumed you'd found a new screw, and that this was.
No, the screw's stuck in there.
Yeah.
It's super glued in. It's not going anywhere. But the super glue stopped holding the joint in place.
Mhm.
So then the joint started going ooh again.
No. That's
So
not-
I had to resort to
that's not
new
good.
means. Luckily, it happened like a couple days ago. So then I could plan ahead, bought some duct tape and some knives.
So how does the knife thing play into it? I didn't get
Okay, so let me show you. So
DIY rundown.
So look, so there's a knife. It starts here. It goes to here. So see, originally I was just kind of like looping around the duct tape, but I was
and
like,
it's just falling off.
I don't trust the duct tape to be
Yeah.
enough strength to hold this thing up because the joint is right here.
Yeah, that's just
So-
an awkward.
so
So you
like-
found an intermediary thingamadiddler.
Yeah, so this is like a
Great.
brace on a leg that's broken. Is
Yeah.
basically how I did it. So I did it across the joint and up here for structural support.
Very nicely done.
Yeah, I like to think it was smart, Dave.
I think it was very adaptive.
Oh my gosh. Hey, I'm very good at last minute fixes with what is available. Dave is claiming there's a $5 tool I could use. Here's the thing, Dave. Super glue. The thing is super glued in place. Also, why do I need to do that to save something that's broken when there will be something new here that is not broken?
Which you no longer need.
No, I think I still need it.
What are you getting another?
I'll tell you
of this-
why.
You're
Because
getting
the whole
another of the
point,
same.
yeah, the whole point of the shock mount is this like suspension system,
Right, and there's no
which
suspension.
now
going
there's
on.
no suspension because it's being anchored with the knives.
Right.
So
Right. What's that thing called again? It's called the.
shock mount.
Oh, I know the shock mount, but it's
Oh.
got a special name.
It's a
Oh,
blue.
man.
The microphone
Blair
is a
Guyver.
blue. Is a
I know
blue
that. I know it's a snowball.
snowball. So if you just
Yeah.
Google blue snowball shock mount,
Yeah,
It should come up.
It's called the something, the roundy thingy, ringer. There,
Ringer
the ringer shock mount.
says ringer right on the.
Oh look, there's Justin's broken one.
Yes. Which broke in the exact same.
We should be like, can we send you back 2 broken ones to get one?
Can we put them together? Get one that actually works.
I think
But
what I'm going to do, though, when I get it, is I'm just going to take it to Home Depot immediately and say, can I have a new wing nut? And so, like a washer or something. Or actually, no, this is what I'm going to do. A wing nut that's longer, right? So it'll go out the other side, and then I'll get a nut for the other side, and then it'll tighten that way instead of me twisting the wing nut. Ha-ha!
Uh-huh.
Ha-ha.
Ha! I think that's what I'll do.
I'm ordering it right now.
Right.
Did she go away again?
Wing nuts.
Wing nuts. We're all wing nuts in the end. Okay. Shipping address. Where am I sending this?
What are you sending? What's happening?
I'm buying her a ringer shock mount.
Oh, she can have mine. Actually, wait. I should
Yours
just.
is broken.
Right, but if she's gonna replace the thing that's because I backed out my bolt, so it's not stuck in there.
But are you ever going to use yours again?
No, probably. I love this. Chris Clark, thank you again for sending this. I love my boom mic. I'm never giving it up. Never giving it up. Mwahaha.
I need to add a location.
A wing nut is a real thing, you guys. It is.
There are several
it is.
running for president.
Oh boy.
right now.
That's not what we were talking about.
Oh, boy.
Right wing nuts? What were you saying?
Hee hee. I'm looking for an address for Blair. Not
Is
an
it like-
ordinary
No.
address.
I thought that's what you were doing.
Blair.
She lives in San Francisco and she's in the Richmond.
Yes. Address.
What is that, Justin?
3 guesses.
A tribble.
Close.
No, it's-
Keep going.
Kitten.
One more shot.
One of those things you put on a microphone to reduce wind sound.
Aha! No, none of them.
Wind kitten. Oh, it's Albert Einstein.
Often though confused. Often confused.
We're a wind kitten.
What we didn't ask about today, Paul Knoepfler, was the likelihood of the puppy monkey baby.
Oh, I can't even think about it. It makes me want to throw up. I hated that commercial. It's terrible. I couldn't handle it. Gord, are you saying I pop my peas a lot?
You have lots of plosives.
I don't think I do normally pop my peas. I don't think I need
those
a
are bad.
pop
Those
filter.
are really bad. I have in this kit. I don't seem to pop peas very much, do I?
No.
But I did get a one of those spit guard things, whatever they're called. Pea filters, pop filters.
Yeah, pea filters.
I don't know what I did with it, and I don't think I'd use it anyway because I think I control my pee pretty well.
Ugh.
Pop guards, pop. They're always helpful.
That's true, but that's like another thing on this contraption. If you think I need it, I'll use it, but if not, then not.
I think you're fine.
Blair,
I haven't noticed any, unless
Do
except
you want
for
me to
right
text
then
you
when
my address?
Yes,
Is that what
please.
that face is? Okay, yep.
Yes, please.
I'm on it.
I'm like scrolling through text messages going, nope. That would be awesome. Thank you.
Okay.
I'm not finding it. Yeah.
The life of how did this happen?
So tomorrow, there's actually a website, you guys. Ars Technica has the link to it, but there's a countdown clock to the gravitational wave announcement. 9 hours, 4 minutes, and 20 seconds, Justin. We will know whether or not our predictions.
We will know whether or not we know anything new to know.
Yes.
Yeah, see, and stuff like that. When they've got the countdown clock, I hope that they have brought something to share.
Well, this is Ars Technica doing the countdown clock.
Well, yeah.
Not actually, but the announcement. So let's click on that. Media advisory. Providing an update on the search for gravitational waves.
Oh.
Uh-huh.
The update is that we've refined our equipment even more than we refined it the last 3 times.
I wonder though if they have a paper coming out. I haven't heard anything about a paper coming out. But I wonder. 10:30 a.m. Eastern time, right?
Wait. It's 7:30 in the morning. Oh, I'll be
7:30 tomorrow morning.
I'll be on the West Coast by then.
Yeah, you'll be awake.
Maybe.
You're already on the West Coast.
Oh yeah, so I'm already here. So that part's fine.
You just got all robot-y.
Yeah.
I did?
Yeah. You're going robotish.
Robot Justin.
It's kind of. You just turned into a Dalek.
No, he's President Roomba from earlier.
President Roomba.
Uh-huh.
Illiterate.
I know, Gord, if they did the big announcement and then we're like, nope, nothing at all.
Actually, it's we were just hoping to acknowledge some cafeteria changes.
It's just too much.
That we're implementing in the next quarter.
You, there.
Wait, you're writing her address for all to see.
Ah!
What are you doing? Who is
Oh my God! Stop it!
Stop! Seriously, what are you
I
doing?
did stop. Thank you.
Are you doing?
Nothing.
Makes no sense.
Nothing. I didn't do anything.
If someone shows up at my house at midnight, it's your fault.
That's not your house. It's just a mailing address.
Okay.
Bad people. Don't do that.
That was like that time I accidentally put my cell phone number on the screen and then immediately someone called me.
Yo, aha!
Oh my gosh.
Yeah, I don't know what's going on with the audio issue.
You are crackly robot voice.
But this must be a connection thing because it wasn't doing it during the show, I believe.
No,
I'm
it's
not
like
using filters. I'm really not. I don't.
because you do
Mute
have
yourself
filters.
and then unmute yourself.
I think it's a Google thing. I'm guessing.
Yeah.
We've run into this. I've run into this issue on the other Hangout that we do. Sometimes people will turn into really crackly robots.
Are you? Is your microphone a USB microphone?
Oh, of course.
Unplug and plug it back in, because
I can't do this. This is So my microphone is not, but the board that goes in is.
because this is what happens with the headsets in Skype after a certain amount of time. So. Can they deliver on Saturday or Sunday? Deliver on the weekends? Cool. Shipping address. La 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 la.
So I have a question. I'm going to start a new round of art that's going to look totally different from the art from last year.
Cool.
And I'm thinking that anyone who in the year 2016, if we zero out in like January 2016, once people have been donating at that level for the required number of months, then I'll start sending them more art.
Cool.
Right?
That'd
because
be
they
great.
certainly deserve it.
Absolutely. I agree with that.
They've continued to support us for this long. They certainly deserve it.
More art. Yes.
And I'm taking requests. I'm not necessarily going to take them all, but someone told me in the chat room earlier, I think it was Ben, wanted me to do a giant otter, and I'm totally going to do that now.
A giant otter.
Giant otter.
Do you want to get this tomorrow or Friday? Does it matter?
Does not matter to me. Whatever. Go for the thriftier option. I just need it before next Wednesday.
Awesome. Well, it's either free 1-day shipping, get it tomorrow. Free 2-day shipping, get it Friday.
Oh.
Free standard shipping, get it Wednesday.
They're all free?
Get it Thursday. It says all free. Yeah.
Okay, so let me think.
It says get it free tomorrow.
So
receive your shipment tomorrow by 9 p.m.
Yeah, let's do tomorrow, because I think I will probably be around. And if not, if they leave me a slip, then I'll be able to go on Friday to get it at the place with the stuff.
Cool. Okay.
Hooray.
Hooray!
Thanks, Kiki. Thanks, patrons.
Thank you. We're giving her a new shock mount so that she doesn't have to use duct tape and plastic cutlery to keep her microphone up, as entertaining as it is.
I'm pretty proud of myself.
That's pretty awesome.
Improvise. I am an improviser.
That you are. You're good at that. It's good. It's good. Where'd Justin go? Is he back? Is he there? Oh, I can't hear him talking at all. So he unplugged it, and now it's not working at all. We did that.
You silent, Justin.
We could change his inputs so he can at least say goodbye. Use your microphone. Change your mic. You're just gonna wave goodbye. You could change your input in the Google. Change the input, or maybe not. Your microphone's muted. Now you're unmuted. Nope. Nothing. Okay. Okay, he's waving goodbye. All right, everybody. Blair, you're tired. I'm tired. I think I got kicked. Oh, I got into for the TWIS. I'm going to have to see what's happening in the chat room. But
That's so weird. The way you sound changes drastically when Justin leaves.
really?
Every week.
Oh, that's funny.
Yeah.
That's really strange. I wonder why it does that.
Google Hangouts.
Yeah. Dave Fredell sent me a link for a
Blab.
Blab. Yep. He's saying, what about Blab, Kiki? Try Blab. I'm going to try Blab. I think my concern is anything I get into. I mean, are we going to have to set up, what are we going to have to set up to make it really work for us? And how much is it going to cost in the long run? So I need to look into things. I really, really like the way that Google goes right into YouTube. So it's just there and I don't have to worry about it. It just cuts time. But we do have these little glitches that we have to deal with.
Which then adds time.
Which then adds time, exactly. Yeah. So it's yeah. We'll figure it out. We'll figure it out what would be the best thing.
It's 2016. I'm sure some opportunities will present themselves.
I'm sure they will. Yeah, Blab does look cool. It wouldn't need Skype, which would be good. It's all good. It's all good. I know. Hangouts are great, except when they suck.
I like that it's very easy to tell someone else how to use them, especially if we have interviews. It's very easy to just be like, just go to your Gmail. We'll invite you. It's super easy. But yeah, then it kicks me out of the room like 40 times. Thanks, Google.
But it doesn't do it all the time. Yeah. Only when you have like a story you're really excited about.
Oh my God. I like shorted out the internet with my excitement.
That's right. OBS is another system. I haven't tried that. No. Anywho.
All right.
I'm tired. I have talks to give tomorrow. I should go get rest.
It's going to be so good.
I make everybody yawn. I made everybody yawn. Ha ha ha. All right, you guys. Open source and free. That's what I like too. All right, everyone. We're going to be back next week, next Wednesday. More This Week in Science. We'll be talking about all sorts of stuff. Thanks for joining us once again. Thanks for a great show, Blair.
Thank you. I had a great time.
I hope everyone has a wonderful World Radio Day, a very happy Darwin Day. Valentine's Day, sometimes you might just want to eat a taco and call it Taco Day. So have a good one. We love you. Good night.